right, everybody, so today I'm going to walk you through how to calculate some measures of spread. So if you have a variable y, then you can calculate measures of central tendency like the mean, the median, and the mode by looking at the most frequent value or the most central value or the most average value. But what about measures of spread around that measure of central tendency? So that can be really important. You know, if all of your measurements come in really close to the mean, then you have strong faith in the mean. But if your measurements are all over the place and they're really wildly variable, then you have less faith in the true value of the mean. And so it's really important to measure both central tendency and spread. So some of the things that we can measure in terms of the spread of a data set. So if you have a y variable and you're interested in its spread, you can measure a few different things. And the first thing I'm going to talk about is the variance. So the variance, we denote the population level variance. Remember this like nebulous value that you can't measure? We call that sigma squared. And if we sample from a population, then we call it the sample variance, and we call that S squared. Okay, now S squared is equal to the sum of every value from I equals 1 to n of every value y sub I minus the mean squared. Okay, and then you take this whole value here and you divide by n minus 1. So I can write that in a couple of ways. I can write it like this. So I'm going to say multiply this whole sum by 1 over n minus 1. Or if it makes more sense to you, you can write it by drawing a line here and writing n minus 1 underneath. So kind of what that means would be if I have my values of yi, okay, y1, y2, y3, y4, dot, 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 all the way to y sub n, okay? Remember I'm taking the sum from I equals 1 to n, so that means I equals 1 all the way to n, and the sample set could be as big as we want, right? So, you know, say we have some values here for our y variables, and maybe they're things like 2, 4, 2, 4, okay, dot, dot, dot. What I know is that the mean of these is 3, okay? And so if I were to do this equation for this set of data, I would say, okay, my first y sub I is 2, and I would say 2 minus 3, because this is the mean, right? 2 minus 3 squared, plus then 4 minus 3 squared, plus 2 minus 3 squared, plus 4 minus 3 squared. Okay, all of those values, I would add them all up, and then I divide by n. In this case, n is 4, n minus 1, which would be 3, okay? And the reason that we have to square these values is that because of the way that the mean works, it's the middle, it's like the central value, right, the average. And you can see this here. If I say 2 minus 3, that's negative 1. 4 minus 3, that's positive 1. 2 minus 3, that's negative 1. 4 minus 3, that's positive 1. Those would all cancel out. The positive 1, negative 1, positive 1, negative 1, they would all cancel each other out, and I would get a variance of 0. So that's not right. So that's why I have to square this deviance, okay? It's the deviation between each value and the central tendency, the mean. How variable is the y, right? That's what variance is getting after. So that's why I have to square each of these deviations. And then I divide by n minus 1, and it's not dividing by n, which might make a little bit more sense because you're trying to get a sense of the total data. We divide by n minus 1 because of the tendency for the sample variance to overestimate the population variance. And so this would be the sample variance S squared. Now what's cool is once we know S squared, we can calculate the standard deviation. Oh, see, I use that word, deviation, right? The standard deviation equals S, which is just the square root of the variance term, S squared. And another measure of central tendency is called standard error. And we can use a number of symbols to signify this. Sometimes it's S sub y, okay? Sometimes it's SE. And what it really is the standard deviation S divided by the square root of n. Okay, so it's, you have the largest value in terms of the measure of spread is the variance. If we take the square root of that, we get a smaller number, but it still tells us about how variable the data set is. It's called the standard deviation. This is commonly used. And then the one that may be most commonly used, probably because it just makes people's graphs look better, but also because of the function of the standard error of the mean, is the standard error, and it's even smaller. And so it kind of constrains the value of the mean. And it's really a measure of how much confidence we have in the mean itself, okay, the standard error. And so these are the three different measures of spread that you'll be working with in the lab today. So good luck.